having used Borg, I didn't see how I could ever live my life without it again, right? And I believed that if I showed people what they could do with Kubernetes, that they would feel the same way, that they would look at it and they would see, I do that, except what I do is so much harder than the way you just did it. But I remember running through those demos and having people in the audience nodding along going, yeah, I get that. So I definitely felt like we were onto something.
You are listening to the Kubelist Podcast, a show interviewing project maintainers for CNCF Sandbox, incubating, and graduated projects. We'll discuss each project to understand where it came from and discuss the roadmap and plans to continue the project. Hi, I'm Marc Campbell. Together with Benjie to Groot, we publish the Kubelist weekly newsletter dedicated to Kubernetes and the CNCF ecosystem. I'm the founder and CTO at Replicated, where we enable cloud-native software vendors like HashiCorp, Puppet, Sneak, Harness, and many others to operationalize and scale the distribution of their modern on-prem software. Check us out at replicated.com. Benjie is the co-founder and CEO at Shipyard, where they enable software teams of all sizes to build, test, and deploy faster and more reliably via their ephemeral environment management platform. Get started with ephemeral environments at shipyard.build. The Kubelist Podcast is brought to you by Heavybit, a program dedicated to helping startups take their developer products to market. For more information, visit heavybit.com. Finally, sign up for the Kubelist weekly newsletter and read previous issues at kubelist.com. On this week's episode of the Kubelist Podcast, Benjie and I were joined by Tim Hockin. This episode is a little different from most, and it ran a bit longer than normal, but I'm excited to share it. We started out with Tim sharing some of the Kubernetes story since he was involved from the start. The conversation then transitioned to Tim sharing a great story of how he's involved in code reviews and how he contributes to the project's stability and maturity. I really love this part of Tim's story on the episode. We're lucky that Tim was involved in the Kubernetes ecosystem from the start and continues to grow the project. Hope you enjoy this episode. Hey everyone, and welcome to another episode of the Kubelist Podcast. As always, Benjie's here with me. Hey, Benjie.
Hey, Marc.
Cool. So let's just dive right in here. We're really excited. Our guest today is Tim Hockin, a principal software engineer at Google. Most of you who are familiar with Kubernetes have probably come across Tim's pull requests and contributions to the ecosystem. Welcome, Tim.
Thanks for having me on.
So let's just kick it off with, I think, a thing that we'd love to hear more is just your background and your story. How did you get started in software and into the role you're at right now?
Sure. Well, I started in software in college. Like many people, I discovered Linux, and I thought it was pretty cool. And I spent a lot of time hacking around playing with Linux. I found a particular affinity for operating systems and kernel-y stuff. When I graduated college, I went to a startup called Cobalt Networks, which you may have heard about. We used to make little microservers. It was hot for a hot minute. When Cobalt got acquired by Sun, I spent my time there doing Linux work inside Sun, which was interesting. And then one day Google came calling and said, we have a kernel team too. So I joined Google ostensibly to work on kernel. Instead, I got shanghaied into doing BIOS work. So I wrote assembly for a bunch of years at Google, helping bring up servers, moved my way up the stack into machine management and data center management. Eventually jumped over to the Borg team where I worked on those same topics there. Worked on this project called Omega, which is sort of a revamp of Borg. And when the Kubernetes sort of opportunity came up, I saw it as something I couldn't pass up. So I jumped onto that. And I've been there, almost 10 years now.
Great. So I'd love to dig in there. There's two different things that we could chat about, the kernel and the BIOS stuff, but sounds like a fun conversation. I'm going to start right now with talking about that transition from Borg to Omega to Kubernetes. Can you share a little bit about, for anybody who doesn't know that background of the progression from Google into what we currently have as Kubernetes? Just share a quick version of that story.
Yeah, sure. So, Borg was born in 2003. So even before I joined Google, and it was well established by the time I started really working on it. It's a very bespoke system that is really designed to run Google's applications in Google's data centers and be integrated with all the rest of the Google ecosystem. Omega was sort of a project to rethink some of the core primitives with more modern ideas, with some of the lessons that we had learned along the way, to see what we could do to make that ecosystem better. it started as a, like, let's replace Borg project. And it really turned into a sort of a research project whose ideas then folded back into Borg. And so, Borg today has adopted a lot of the ideas from Omega for many reasons. Kubernetes was, designed at a different market, right? It's not Googlers. It's not custom software. It's off the shelf, open source things. It had a lot of different requirements than Borg. So we took what we thought were the best learnings at the time from Borg and Omega and wanted to build them into the version 0 of Kubernetes. Retrofitting major features onto a system like Borg turned out to be very, very difficult. So starting from scratch with these ideas was more approachable.
And the intention there with Kubernetes was not to be used as an internal replacement for Borg. It's kind of like the open source community giving back. Is that correct?
More or less, yeah. I mean, look, by the time we were working on Kubernetes in 2013, Borg was already 10 years old, right? So it already had thousands and thousands of features that were really custom built for serving ads and search and Gmail. And most applications in the world would never, ever need those capabilities. Kubernetes was designed to be used by the rest of the world. And as such, we focused on the requirements of the real world as opposed to Google, which, if you're a startup and Google comes to you saying, hey, we want you to customize your product for us, you might consider running away. It's very difficult to have such a big dominant customer who has such weird, unique requirements. So even up till now, we've more or less ignored the Google specific requirements in favor of the broader industry requirements.
As a Kubernetes user, can you give us just 3 of those requirements just to blow our minds with the scale and the problems that you guys are dealing with over there?
Sure. Look, everything at Google runs on Borg, and that includes cloud. So think about the sorts of requirements you have from your container management system when the containers you're running are actually VMs, which have to be long-lived and plugged into arbitrary overlay networks with static IPs and identity built into all of that. So there's a ton of requirements that go into Borg just to serve cloud, right? Just as a reminder, like something like GKE is containers running on VMs, running in containers running on Borg. So, those sorts of requirements, or take something like search, which finely tunes the number of machines that they have in a cluster based on historical information and predictive information about how the search traffic patterns are going to look, right? Those clusters are significantly larger than the average Kubernetes cluster and bring a whole host of requirements for scalability and reliability that Kubernetes just doesn't have, right? Borg is just architected differently.
Totally. I mean, it's always been fascinating to me that you guys were Google in particular was so keen to open source and create this Kubernetes project. What was that like, getting that kind of through the brass at Google, I guess would be my question.
Yeah, it was a journey for sure. We covered some of this in the Kubernetes documentary. I don't know if you've seen that yet, but it was an interesting exploration from different perspectives of how we got this through. We, the engineers on the ground, we saw this Docker thing happening and we thought it was going to be big. And we knew that it was only a piece of the solution. We could all see that if that was the Borglet, then we needed a Borg master, to use Borg's terms. And that's where Kubernetes really could be important. There were people in the call chain who thought that we would maybe be giving away the golden goose, or that we would be empowering the competition too much. But ultimately, cooler heads prevailed, and we realized that this whole thing, this evolution was going to happen. And we could see it happening. We could see the beginning of it moving, and we had a clue which direction it was going to go. And we had really one opportunity to be part of that. Otherwise, we were going to just be along for the ride.
Right. And looking back historically, I think about MapReduce and that white paper and Hadoop. And, Google in the past has released pretty significant white papers that have created entire industries. So it seems like you guys kind of were like, hey, you know what? Like, maybe it would be good to lead this and make sure that it happens the way that we want it to happen, rather than or help shepherd it, maybe is the right term. Is that kind of maybe the change in thinking was part of that?
Sure. I mean, we definitely learned from Hadoop and MapReduce. Not that could have been different. Like the organization and the technology just wasn't set up for us to have done that at the time. But we definitely looked at those sorts of experiences and thought that we could do better than that. We could have more impact than that, both for the industry and for Google as a business. And ultimately, that's the argument that won out, was we could actually not just make the world better, but we could actually build a business around this, that this was a product that we could sell that customers would be hungry for if we could just show them the vision.
And going back a second, I did watch the Kubernetes documentary. The quality of that thing was hilarious. I thought it was like going to win an Oscar. Not hilarious. It was just like really well done. We'll put a link to that in the show notes, but it's a really great history that dives into a bunch of these questions. So I think it's super interesting, and I couldn't recommend it enough.
So transitioning to the brass at Google, as Benjie put it, has given their blessing, and you decide you're going to create Kubernetes, not necessarily to solve Google's problems, but your descriptions, you're learning from in repackaging the Borg primitives in a way that's more consumable by an open source project, and folks that aren't running necessarily at Google scale, but still can benefit from some of that. You saw this opportunity and you went and you started spending most of your time or all of your time at Google working on Kubernetes in the early days.
Yeah, we knew that we needed to get the thing off the ground. So we needed a core sort of seed team. And some of the folks up in Seattle built a prototype of what approximated Omega and Kubernetes. And that was built on tools like Docker and Go and SaltStack and a whole lot of bash code to glue it all together. And they showed us some of their demos of what they were working on, which aligned pretty perfectly with the way that we were thinking about Borg, and Borg as a service was sort of the goal at the time. And those two things together added up to an opportunity that needed people to work on it. And so, a small group of people sort of cracked off from their main projects and started working on this full time. We had the support of our direct management, which was great. Go and figure it out, they said. And so we did. Very quickly, we needed more and more people to work on it. And so we went and recruited from the best of the best, the people that we'd worked with in the cloud organization, the people we'd worked with in the Borg organization, and brought a ton of that context to building Kubernetes and getting the run up to that announcement at DockerCon. That really was the moment the snowball started gathering speed.
The team there was making several bets that had to come together to work, right? So obviously with Borg and containers had been around for a while, you had expertise in containers, but Docker was new and obviously gaining traction as the commoditization and making it easier and easier to run containers everywhere. But on top of that, you just mentioned that the early versions of Kubernetes, it was written in Go, which it's not the language today that it is today. How did you think about that and making the decision to say let's keep this in Go and go all in and build the entire stack in Go?
So that's an interesting story in its own, I think. I came at this project from a C++ background. Most of Borg is written in C++. We had some components in C++ that we thought maybe we could just open source these things directly. But some other people came at it from the Java point of view, and they had a lot of Java experience, and they thought we have some Java components. Maybe we could just open source those and use them directly. And ultimately, the prototype was written in Go because Go is a language that is excellent at writing code quickly. It has a good standard library, good support for things like HTTP, which were at the center of a lot of what we were doing. And so we took the prototypes and we ran with them for a while. And when it came down to the discussion of what are we going to do this in for reals, one of the concerns that we asked was, well, if we're going to open source this, it's really critical that we get a community, that we have other people who contribute to this. And, when you look at open source projects that are wildly successful, there aren't a lot of C++ projects that fit that category. There are a handful, but they're not many. C++ is sort of unapproachable by many people. And in fact, a lot of people just don't even want to approach it. And, not for bad reasons. Java has its own baggage. Go was new. It had a decent ecosystem. Docker was written in Go. etcd was written in Go. And so those things together said, let's see what we can do with Go, right? The Go team is here, so maybe we can talk to them if we have problems.
Yeah. That's awesome. And I think, obviously just you've added to that ecosystem a ton. And like, there's a lot of Go we write all of our code in Go. So I'm a huge fan, but I want to jump back. You said look, we were building the first prototypes in the experimentation for early Kubernetes in Go. And then we took a step back and we said, what are we going to write this in for reals? What's the version 1? What are we going to go for? That's an interesting concept that I think is not necessarily immediately obvious when you look back on it. There was not a clear path of before we write the first line of code, we know what it's going to take to 1.0. Did you have a certain amount of time, or what were the metrics that you were looking at for that during that experimentation phase of early Kubernetes before you said, okay, now we need to settle on a language. Now we need to settle on an architecture. Now we need to actually write this thing in a way that's going to be production grade. It's time to stop experimenting, time to start building.
I don't think there was a moment when we said it's time to switch over. But as we started seeing the prototype grow, it was a case of, none of us know Go. Actually, very few of the people on the team knew Go very well. And in fact, we've been accused of writing Go code that looks like Java, which is probably true from the early Kubernetes code. We really thought about, what do we know? What can we get done? What has this ecosystem? In fact, the very first version of sort of a proto-kubelet was written in Python, and it was basically shell scripts embedded in Python strings that we're calling Docker, right? So how's that for a stack? And, we thought Python probably wasn't the right language to build a large production system in. There's some internal documentation in Google that says, really, please don't do that. And the generally accepted successor to Python for that niche is Go. So that carried a lot of gravity there. It sort of was a component by component decision, right? We had a thing that was sort of the kubelet to Omega, which we called Omelet, which was written in C++. And we thought maybe we could just use that, right? Maybe the API server, that the prototype that's already been written in Go, that's fine, leave that. But we'll write the node agent in C++ and we'll be able to use the open source libraries that we had. But ultimately, some folks like Joe argued that the open source communities around C++, the libraries for doing stuff in C++ just weren't nearly as good. And having a polyglot core system was really not going to be a great idea.
Yeah, I think that decision early on to not have a polyglot situation is one of the big reasons. I know a lot of people that just have really dove into Kubernetes and loved it. And I think it makes it a lot more accessible. So Tim, I just looked up an email that you and I have from 2015 when I met you at the Kubernetes Architecture and Use Cases New York Kubernetes Meetup, November 5th, 2015. And that's when I really learned about Kubernetes. I just think that it's amazing where we are 6.5 years later. What I want to know is when you went around proselytizing Kubernetes and all this stuff, did you have any idea that it was going to be this? Or were you just this is really cool, I'm loving it, but who knows what's going to happen? Or did you know? Because I felt when I was listening to you present that night, I knew what this was going to be and I knew it because I heard your excitement. I heard your voice. You were explaining this stuff. All of a sudden, a canary deploy was not a dream that I would have one day. It was I could do that. So I'm just curious, did you actually know? Was I right? Were you did you know? Or did I just get too excited? Or what do you think?
Well, I would try not to take too much of the credit here, but I had a strong feeling that we were onto something good, right? Having used Borg, I didn't see how I could ever live my life without it again, right? And I believed that if I showed people what they could do with Kubernetes, that they would feel the same way, that they would look at it and they would see, I do that, except what I do is so much harder than the way you just did it, right? And in fact, I remember that meetup because I was trialing one of those tools that I had written to sort of script demos. And I remember running through those demos of things like a rolling update. And these were really sort of primitive compared to what Kubernetes can do today. But I remember running through those demos and having people in the audience nodding along going, yeah, I get that. Yeah, that makes sense. So I definitely felt like we were onto something. Now, truthfully, if you had asked me then what does success look like in 6.5 years, I would not have painted you a picture of what today is. I don't know what I would have said, but it wouldn't have been this. This is sort of wildest dreams territory. And it's still growing, right? I mean, every release is bigger than the last. So it's, super, super exciting, but no, my crystal ball is not that good.
I mean, I think it was, I couldn't tell you how excited you got me, which actually brings up a little anecdote that I love to rib Marc about. I went to that meetup at the time. Marc and I worked together. I was working at Replicated, and I came to LA for a big meeting with 3 of the best engineers I know, Dimitri, Ethan, and Marc. And I am easily the worst engineer in that room, but I had seen you, and we at the time were making a decision for the Replicated scheduler. Do we keep kind of doing our own homegrown thing? Do we go all in on Mesos? And basically I was convinced that Kubernetes was the thing. I couldn't quite articulate myself because I just kept trying to repeat what you were saying, but I did not do that great a job. And so I love to talk to Marc and give him a hard time, where he told me that I think Mesos is going to win this thing. That was a long time ago. Obviously, things have changed, but trying to copy what you said was a direct influence on me. And I just, it literally something clicked in my brain when you did that. The other thing, I remember that bash tool, or it was like a scripted bash thing, and you were doing this demo, and what, do you still have that? Is that a project that we can point people to? Because that thing was great.
Yeah, so it was something I slapped together in the Kubernetes contribtor when we had one. And we don't anymore because it just turned into a breeding ground for rotted stuff. But I took it and forked it into my own personal GitHub. So if you go to GitHub/T-Hockin/Microdash demos, I've got it still. It's a little shell framework for writing these scripted demos, then a bunch of examples of Kubernetes demos that are built around it. And it emulates typing. It throws some randomness into the output so that it looks like you're typing. So if you're really kind of want to play a trick, then you can sort of wave your hands over the keyboard and look like you're typing, but never make a mistake. And then you just hit enter and it will run the next command for you. It's real demos. It's really running those commands. It just makes it so you don't have to remember to type them, right? How many times have you watched a video of somebody who's clearly cut and pasting from a doc somewhere, or control R-ing things from their bash history, or whatever they're doing to get it done? And it's sort of tedious. This takes away that tedium and makes sure that your demos are reproducible.
Yeah, and like you want that when you're doing a demo too. Like you want that like authenticity, but like you get up there in front of a group and like a bash command isn't working, and you're just like, wait, I don't know why this isn't working. Yeah, like Benjie, we're gonna have to find a link, see if we can track down that meetup that you were at when Tim presented. Any chance we can find a recording or something on YouTube of it and put it in the show notes here, because I'm gonna need to watch this and see what inspired you 6.5 years ago on Kubernetes so strongly that you still talk about that.
Yeah. Oh, I'll never stop. It was the one time. It's like, a broken clock is right twice a day. So I have to make sure everyone remembers that. So by the way, is that tool, Tim, where can we get that tool? Is it called Milli Vanilli? What's the name of that tool?
It's cleverly called Microdash demos. I'll blop you a link and you can paste it in the notes.
We'll make sure to do that. So switching gears a little bit, let's go to today. What's a day in the life of Tim today working within the Kubernetes ecosystem? So we're recording this right before, I think 1.24 is locked, I believe, the day before. So thanks for coming on, by the way. But what does it look like? What's a day in the life of Tim? What's like the big challenges? And maybe what's the current thing on the top of your brain of the big challenge?
Sure. Yes. Tomorrow is the code freeze for 1.24. I looked at my calendar for this week and I thought, why do I sign up for these things? But I love talking with you guys. So this is an unusual week, but my normal week within Kubernetes is 1 or 2 SIG meetings during the week, where we have these Zoom calls where we get together and talk about specific interest areas. I pay attention to SIG networking, which is my big one, multicluster, and sort of architecture core stuff from the system. Those are my big SIGs that I pay attention to. The average week is probably reading 10 times as much as I write, doing either code reviews or KEP reviews. KEPs are our design docs, and giving feedback on how to integrate ideas with the rest of the system, looking for the pitfalls with some creative new idea. Where is it going to fall over? Where is it going to intersect badly with some other feature? This week in particular is all code reviews, right? So it's the biggest of the big code reviews that haven't been reviewed over the last couple of months because they're so large and daunting. Well, now the pressure is on to get these things reviewed in the next couple of days. So I'm spending a lot of time doing code reviews, which realistically involves flipping back and forth from GitHub to a code terminal and searching for context and figuring out what's going on and running tests and oftentimes checking out the PR and running it, throwing some logs in to make sure that it does what I think it's supposed to be doing. Also, I spent some time looking at customer issues and user issues, trying to figure out what's going on, what, is this thing that they're filing a real bug, because Kubernetes is full of them, and trying to help triage there. The community at this point is so large and successful that, my own role is less critical than it used to be, perhaps. And so I try to pay attention to the things that I know I can offer somewhat unique input on as opposed to the everyday things.
I am not a contributor today to Kubernetes. As to benefit the community, I've stayed away from writing code. But I'd love to hear a little bit about the code review process, actually. What's a core contribute? So you get a PR, then you run it. Just talk to me about what an actual code review looks like. And then also the testing. How do you test it? I want to understand how you.
Sure. Well, it depends on the sort of PR. I mean, there are some that are easy and there are some that are not. At this point in the code review process, or the code freeze process for the release, the ones that are left are the ones that were not easy. So, thinking about the reviews I've done over the last couple days, right? There's some that are deep in kubeproxy. So, I've spent many hours staring at this code that's restructuring the way IP tables rules are being generated, for example, convincing myself that the changes make sense, that the right use cases are being considered, that the code itself is readable enough that I can comprehend what's happening here, that if I was forced to explain to somebody what's going to happen on their system, that I could reason about it. In many of these cases, it was check out the code and, stare at it in a code editor, jump from, call site to function definitions, make sure that they make sense, offer suggestions sometimes on naming things that would make more sense, or asking questions that will lead to either, yeah, you're right, that was a bug, or comments to explain what's going on at that place. Testing wise, I'll build it. Like in this case, I built a kubeproxy component, pushed it out to my test cluster, maybe added some debug logs so that I could convince myself that the right paths were being hit, compared the old and the new state to make sure that it worked well. But that's all the manual stuff. We do have a pretty robust CI system. So when these pull requests are pushed in the first place, we trigger a CI build that will spin up a whole cluster, run our battery of end-to-end tests against it, feedback through GitHub, how did it go, what went wrong? And that gives me a lot of confidence. The fact that was green already meant that the contributor had already fixed all the obvious stuff.
So those end-to-end tests, my brain swirls when I'm trying to think of what that looks like. Can you give me just a super high level, give me a few examples of how you do end-to-end tests when changing the Kubernetes? If I'm changing a kubelet, is this to use open source projects, or how end-to-end is it, I guess?
It's literally spin up a cluster. Depending on which test cases, it may either be an actual cluster on VMs, or it might be a kind cluster, Kubernetes and Docker, and spin up a pod, for example, with a particular specification, and then verify that, in fact, it is running and it is serving the traffic that we expect it to serve, that it got scheduled, that the kubelet ran it, that the volumes that we expected to be mounted are in fact mounted. Or in the case that I was looking at this week of kubeproxy stuff, it was make sure that when I go and run a pod and create a service for it, that all the different flavors of traffic that we expect to be able to reach that pod can in fact reach that pod. We turned on a load balancer, which actually went out and provisioned a cloud load balancer and then run traffic through that load balancer to the backend pods to make sure that it was in fact serving from the pods that we expected it to be served from, and just try to mutate the various input modes there and make sure that the changes are correct, which give us confidence in the totality of the change. Right? Obviously, we have unit tests that say, the expected output is X, and we ran it and we got X, so that's good. But the end-to-end test is the thing that really gives us the confidence to say, we didn't forget something important, because the end-to-end tests encode our conformance suite. So if we did forget something important, then hopefully the end-to-end test would catch it and say, hey, this particular thing failed. And then you'd go and figure out, well, why did that traffic mode not work?
Yeah, I think with the surface area that Kubernetes has and how many other services depend on and count on, these interfaces, CNI, CRI, all of the CSI, Kubernetes to work, you need that automation in order to have any kind of confidence pushing it out. But I want to actually go back and chat for a second about that manual process you were talking about. I think that happens often a little bit, behind the scenes. Nobody really sees that happening. The amount of time and effort you or somebody in a role like you are putting into really detailed looking at that PR and deciding spinning up and you mentioned you replace the kube proxy on your local cluster to test it out and really get comfortable with it and understand how it works and keep that knowledge so you understand. That feels like a hard thing to scale. So how do you get folks outside of Google and how do you grow the people that are in that position of trust that you have to be able to do that?
That's a great question. And, it is sort of existential to the project that we fix the bus factor, that there are people who can do those things. So, picking on the same example, there are other people within SIG Network who would do the same work. In fact, probably did do the same work that I did to convince themselves that these things work well. So it's not just me who does it. But it is probably still a relatively small list. It's probably less than a dozen people who do this on a regular basis. And so, I'm always working with the people who show up, the top contributors, the folks who are willing to take these bugs on how our techniques work with each other, we share each other's tricks and get better at doing this process. In this particular case, I spent probably combined over the last week, 10 hours on this one pull request, just making sure that it works. But it's a really important pull request that changes the way things work internally based on, clarifying some under-spec'd areas of the system. And so it's really important. I'm certainly not going to spend 10 hours on every pull request, but there's always a handful of these things that require that level of attention to detail. And there's this voice in the back of my head that says, wow, this is just too complicated. I should just ignore it. Maybe it'll go away. But the truth is, these are important changes that the system needs to be able to adopt, right? In this particular case, we found some set of corner cases that just were inconsistent and don't work well and weren't really well documented. And new features, which were bringing really important functionality, were going to make the problem worse. Right. So this person said, I'm going to step up and I'm going to refactor this fairly intricate subsystem. And I'm going to send you a giant pull request that is really well factored into nice commits. But you have to convince yourself that this works. And saying no to it would mean saying no to sort of all the subsequent capabilities that we would like to build into the system. So it was important.
Yeah, I think that's so important. Kubernetes, I actually remember early days, kind of going back to earlier conversation when it came out, it wasn't high scale at all. It was very, limited, but it had a lot of potential and everybody could see where this thing is going to go. And as the projects matured over the years, the complexity of it actually has gone up a lot too. And, that's people trust, when your 124 code freezes now, people are going to trust when you ship 124 that they can put it on their clusters and run it in production. And you don't want to ruin that trust by introducing regressions or being too careless, but you also want to balance that and, encourage community adoption. And you don't want to default to saying no to every PR that comes in either. So it's tricky.
Yeah. You touch on something kind of really important there. There's a lot of opportunities for changing things that would be simpler or make the code cleaner, but would represent, breaking some small corner case that maybe used to work. Maybe it shouldn't have ever worked, but it did work. And we've had this debate over and over and over again. And repeatedly, we fall on the side of don't break users. Even if this thing was not supposed to work, if it did work, it's effectively part of the API now. And you get this struggle between, well, it only works in these certain circumstances and not in these other circumstances. So we should just fix it and simplify it and make it consistent and not work in all cases. And I find myself, I'm attracted to those arguments, but I have to step away and say, no, we don't do that, right? If we can make this work, then we have to keep it working and just document that this is a special case. And for historical reasons or for good reasons, whatever the reasons are, we're going to keep it that way. And I think that is, really shows the project's commitment to being enterprise ready and happy to make the customers successful. We're not going to just say, well, that was a bad idea, we're taking it away.
Yeah.
What you're describing right there is kind of the constant struggle of every engineering team for every product that is a software application. So it's kind of, for me personally, as someone who obviously has a company outside, this is literally the conversation I think I have once a week of, hey, the customer is always right, even when they're wrong. How do you balance that? And I think that what you just articulated is a really challenging way for all of us engineers to think about things. And I can commend over the years at Kubernetes, I definitely have done some things that I should not have been doing, but it never broke with no subsequent releases. So thank you personally for that. I mean, yeah, it's interesting how much as an open source project, Kubernetes really does have, I can't imagine the number of users that it has, but you have to keep all of them happy. And obviously, I think Marc spoke about this earlier. You guys do a great job of that. And so it's just impressive. So speaking of which, I wanted to ask you, what is the most surprising usage of Kubernetes that you know about that you were just like, oh my God, they're doing that? Oh, that's so cool. Maybe you're like, oh crap, we have to keep this feature in there. But give us a few examples of some of the things that are just like mind blowing as to who's using this thing for what, your baby for what.
Yeah, well, I mean, there's a few that I think are interesting. I tweeted at some point, I think it was at a KubeCon keynote, when the folks from CERN were talking about how they use Kubernetes to run the super collider. And that blew me away. Like, that is so cool, right? Like, that is world-changing science, and Kubernetes is down there helping them control it, it just blows me away. Even now, it was years ago, and just saying it out loud still gives me the chills. There's other demos that I've seen that are mind-blowing too, like Kubernetes running in an airplane, right? Like running inside the US Air Force in fighter planes doing, stuff I'm sure they can't tell us about. That is not what it was intended for. It's awesome that it works. I haven't heard any specific requirements from them, things that didn't work, but wow, that's a pretty strong bending of the system, in my opinion. The other one that I thought was interesting that I didn't really see coming is people using it as a software distribution mechanism, right? Building their SaaS products that they ship to enterprises and bundling it with an embedded Kubernetes cluster and saying, just run this, and this will turn on a VM in your, VMware or whatever, and it will run a Kubernetes cluster on that VM, and it will run our software in that Kubernetes cluster. And they're using Kubernetes as a way to say, well, we don't have to deal with some of the problems that we used to have to deal with. The Kubernetes cluster isn't part of the surface area. It's not part of the product that they're selling. It is just a mechanism for them to deploy their stuff, which I think is pretty cool.
I think it's super cool. I think you just described Replicated, by the way. And I don't work there anymore, so I think I can say with less bias how effective Kubernetes has been. And I've observed what Marc and the team have done over the years, and it's really impressive, the portability that Kubernetes gives us. Again, because of these standards that you guys have built over the years. So I couldn't agree with that more. One that I don't know if you're a frequent listener to Kubelist, Tim. I'm sure you are. But we actually had the folks over at Rancher on, and they told us that there's somebody running a Raspberry Pi Kubernetes cluster in a satellite. So, like in space.
That does not surprise me. I joked with somebody from NASA at a KubeCon, and I just said, hey, when you're ready to put it up on the space station, you let me know, okay? just give me a call, because I'd like to watch. Don't
you think you should get a ride or something for that? Like maybe they need you on-prem to help install in case there's an issue?
That seems fair to me. If anybody from NASA is listening.
Yeah, maybe we could get you on one of the next SpaceX flights. Well, look, I think that I've heard a bunch of other stuff. And another little anecdote I'll share, maybe 15 years ago, I had a family friend who was actually a test pilot. Maybe it was longer than this. And he was telling me, and this was when he was testing out the F-22. So this is years and years ago. He was telling me that those were running a Windows subsystem or running Windows. I swear this was like 1990. This is probably Windows 3.51 running in 2000. And he was telling me that mid-flight, he would have to reboot half the systems, like literally like flying. And this was a fly-by-wire system. So I was like, I don't understand. How does the plane not crash? So I never quite understood that. So you saying the fighter jet use case makes a whole lot of sense to me, just bringing back another old anecdote there. Yeah, I mean, I've seen all kinds of crazy stuff, and us over at Shipyard, we also are running arbitrary workloads, same type of thing. It's just kind of crazy what this has unlocked for us all.
Yeah, I mean, at the end of the day, everything is software, right? And like, there's nothing that isn't software anymore. Whether you're talking about enterprise company management, or whether you're talking about cloud scale stuff, or whether you're talking about retail and, running all of the little devices that are inside of, a fast food place. It's all software, and it sort of boggles the mind. 90% of the software in the world, or 99% of the software in the world will be bespoke for those sorts of applications. And they all need some way of deploying and updating and canarying. And especially with the rise of things like mobile ordering and, customer, the customer cards, it's sort of like the future of, you see these things in movies, right? When you walk into the Gap,
Minority Report. Right?
Minority Report. Thank you.
Yeah.
Right. Like, we're kind of there. Maybe it's not scanning your eyes, but it sure is your phone telling it, hey, I'm checking in.
Yeah, that's true. I mean, Chick-fil-A is running, I think, local edge Kubernetes clusters at each one of their franchises. So yeah, we're there.
Yeah, exactly.
So let's transition for a minute here. Tim, so you mentioned earlier that 124 code freeze is tomorrow.
Yeah.
Are you involved at a high enough level in the project, in the overall Kubernetes project right now, not just the SIGs that you're focused on, to be able to kind of share some highlights, like the TLDR for what people like? I imagine this episode is going to be released post code freeze, but before 124 makes it out. So what should we be looking forward to in 124?
So that's a trick question, because Kubernetes is a loosely federated set of projects that all check into the same code base. There isn't a top level theme or goal anymore. We don't do top down development in general. So I can tell you sort of what the hot things are in the SIGs that I'm paying attention to, but there isn't an overall, like, this is a XYZ release where we're going to focus exclusively on features that do XYZ. It just doesn't work that way. There's always APIs in various states of evolution, right? We have a pretty formal process for evolving APIs. So every single release, this one not accepted, there are APIs that are moving from alpha to beta and APIs that are moving from beta to GA, and features that go with those APIs, whether they're command line features or server-side features. And often they're sort of verticalized within a SIG. And I don't mean that in a negative way, right? Often we in the industry, we talk about siloing being a bad thing. I don't mean that as a bad thing. I think actually our SIGs do a pretty decent job of giving people who have common interests, common goals, a space to work on those common goals while still being, permeable boundaries between those groups. So I can't answer the question from a high level. What's going to be in 24? A lot of things. We have a release team who spend an enormous amount of human energy pulling together all of the enhancement proposals that are going to be in the release, right? That deadline was a couple months ago. And I think there were north of 40 enhancement proposals that are going to be changed in this upcoming release.
That's great. Yeah, and it's going to be the newest release when we all are, hopefully, over in Valencia at KubeCon in May.
When you are at KubeCon, or you have been there in the past, I think it's interesting. So for people going for the first time this year, or maybe the next time, what do you think of the biggest things that you've gotten out of being at KubeCon over the years, and just being face-to-face with all these people? What are some of the highlights of things and conversations you've had?
Well, I'm not sure that I have the normal KubeCon experience, but I think KubeCon has a amazing technical tracks. So first of all, like, massive kudos to all the people who do those proposal reviews. That is an enormous amount of very hard work. I've done it. I'm not on the program committee right now because, oh my God, is it a lot of work. So massive props to those people who put together great conference, first of all, on the technical content, and to all the speakers and everybody who presents. For me personally, the thing that I value out of KubeCon is being able to get together face-to-face with the people that I interact with primarily via GitHub and Slack and Zoom, putting a face to a voice or a real three-dimensional figure to a person, being able to sit down and have a meal or just chat in the halls is so useful and productive. It is how, in my opinion, the biggest and hardest decisions really get cracked. And it's how we build the sort of camaraderie and friendship, really, that lets us build a project of this scale, trust each other to make good decisions without second guessing each other, and to have even conflicts and disagreements when we need to, and still keep everything, friendly and happy. I've certainly seen other communities that don't have that. And I think the real life connection matters a ton.
Yeah, I think one of the things, and actually in your documentary, the documentary about Kubernetes, they broached this a lot. I think that the community and the building of the community is probably the real amazing victory of the Kubernetes project. Like it's so civil. I know Marc is actually one of the crazy people that helps with setting up the KubeCon. I think the the runtime track this year, Marc, is that right?
Yeah. Like the whole reviewing proposals. It is, Tim, to your point, like there's so many great proposals sent in for folks who want to speak. And like the bar is just like, I think every KubeCon it's higher and higher, like the technical track for the sessions. But I think it's also like super interesting to dig into what you were talking about, like that trust, the camaraderie, the friendships that you actually build. You go there, you're in person and you have that, like, people are fully present. Like, I don't know, when you leave the events at the end of the day, you're like exhausted because we're so engaged in all these conversations at a different level than you are when you're like connecting over Zoom and remote and kind of jumping from meeting to meeting.
Totally. Absolutely. I get worn out. Usually my voice is blown by the end of the first or second day, but it's the best kind of laryngitis, right? It's yelling over the crowds of excited people who are just doing fun stuff. And there really is no substitute for human contact when you're building this. And, not to get too political with it, but with the whole return to office and remote work situation in the world, we're on the pivot point of many companies calling for return to office. And while I very much appreciate my ability to work from home, right, and I can do events like this recording from my comfortable desk at home, when I go into the office and I have meetings face to face with people, it is a different experience.
I actually remember the first time, we were obviously like everybody else, COVID, we went all remote, and a little over a year later, there was, between a few different waves, a few people got together in an office, in a WeWork space for our company. And we were just working through a hard problem. And it was the first time we got together in person for over a year, and we had a whiteboard in the room. And it was just like, I miss this. Like, I so much miss this. It was so great to be able to do it again.
There is no substitute for a room and a whiteboard.
Okay, so Tim, we're going a little long here, but this is pretty darn engaging. So I'm going to ask you a few more questions that I have, if that's okay. I wanted to know, looking back, what are you the most proud of? And also, like, kind of a lot of us, we're building software, and we all have regrets, and we're all like, oh my God, why did I do that? Or why didn't I do that sooner? And I just thought maybe you had some very interesting perspective on that around the project.
I find myself in an awkward place within this project where I seem to own the networking subsystem, but I'm not a networking person. I really don't have any networking background. And so I came at it from the perspective of application developers and what would I want to work? How would I want it to go if I could have anything I wanted? And then I just said, let's do that. And I've had many networking people, real networking people, capital R, capital N, real networking, tell me that I have made their lives very difficult. And I'm okay with that because I have, I think, made the lives of developers easier. So if there's anything I'm proudest of, it's probably that focus, that ability to say, I understand that this is hard, but hard is okay. We can do hard. and to keep this sort of relentless focus on what do developers need? What is the experience that they need? How do I empower people without getting in the way? That's really where my focus has been and continues to be. And yeah, there's definitely a lot of things that I probably would do different if I could go back in time, but I can't. And I'm okay with that. I'm just going to live with it. That is a lesson that I've had to learn through this project. I'm okay with it.
Well, when Kubernetes is powering a time machine in 17 years, maybe we can have some interesting recursive fixes.
You know, to borrow a phrase, right? There's only two kinds of systems in the world: the ones that people complain about and the ones that nobody uses. So as long as people keep complaining about Kubernetes, as long as the venom keeps flowing on Twitter, I'm a happy guy.
I think that's very fair to say. I mean, I kind of want to like have you go be a Tony Robbins for my engineering team over here, because just the things that you're saying just make a whole lot of sense. But, you know, we're not building systems because they're easy. We're building systems because they're hard, and we have an end user that we're trying to make their life. I mean, personally, I like to try and make people's lives magical. And the end user of Kubernetes is obviously developers. Well, maybe you could argue the end user. But anyway, so yeah, I mean, I think approaching these problems not from how hard is it to do, but how valuable is it for the consumer, I think that shines through this project. There's a lot of stuff there. So you're happy with YAML is really what you're saying?
Well, that's a different question. I think I posted on Twitter a few weeks back that I think everybody should use a variant of YAML that isn't the sort of default that we use, where it looks a lot more like JSON, but it has comments. And I think that would be better. Not everybody agreed with me. Let me just say that. But, you know, as it goes, YAML is fine. Except for the whole Boolean interpretation stuff. That was just a mistake.
The yes and no. And yeah, there's some crazy things there.
Yeah. I've been proselytizing to not add a new YAML. I'm okay with YAML. It's just like we got to stop having everybody add a new YAML on top of a new YAML on top of a new YAML. But that's neither here nor there. Okay, so one thing we didn't touch on, and we're going to wrap up pretty soon, I promise. But like, what are the biggest challenges that are keeping you up today? What are the things that you want to focus on, or that you want someone else to focus on, that you think is kind of in the immediate path for Kubernetes to just keep growing and being what it can be?
The banner that I've been carrying of late, or the windmill that I've been tilting at anyway, is multicluster. And here's why. From the beginning, we built Kubernetes as a walled city. And as long as you're within the walls, we have running water and we have paved streets. And, you know, occasionally there's potholes, but overall it's okay as long as you stay within the city. And we put our fingers in our ears and pretended that the world outside the city wasn't important and didn't really exist. And, you know, we all knew that that was false, but it turns out that as you get successful and you get adoption, you cross the chasm, as it were, it becomes really important that you have doors in your walled city that lead to reasonably treadable roads onto other cities. And my analogy is breaking down. But the biggest problem that we have is integrating Kubernetes in real environments is underserviced. And whether that means dropping a cluster into your enterprise network and having it work from non-cluster clients or with non-cluster servers, or integrating it across multiple clusters, across regions, or across providers even, there are reasons that people need multiple clusters. And those reasons can't be denied or designed away. They have to be dealt with. And so the thing that I've been most focused on for the last year or so is, what are those reasons? How can we best serve the people who need to leave the city and find their way to some other destination? So I've spent, a lot of time looking at it from the networking perspective and from the sort of application perspective, from the administrative point of view. There's many different problems there. I think that is the place that we need to go next. Not to say that Kubernetes is done on a single cluster basis. It's certainly not. There's a lot of capabilities that we can add, but they are getting more refined, more sophisticated, maybe is the right word. So they're having less return on each investment, maybe diminishing returns. The real value is getting out of your cluster and into another.
And that's something you see that like might be interesting to bring into Kubernetes core? Because these folks might be solving that today with other layers, right? Like a service mesh or other tools that they're like applications that they'll bring on top. You actually see this as like fundamental to the next step of Kubernetes right now?
I want to be careful because I don't think Kubernetes can or should try to be everything to everyone, right? We should not in-house a service mesh into Kubernetes, although we kind of already have one in the form of kube services. But it's not my goal to say absorb Istio, right? It is, however, my goal to find the things that Istio or other, service mesh is one example, that other systems that build solutions, what do they struggle with? What can I do to make it easier and better and safer to build those systems and to make it more consistent and more normal to use those systems, right? As an example, we started the Ingress project many years ago. It sat in beta for a very long time because it was a sort of an unsatisfactory API. We finally did GA it with the acknowledgement of, it is what it is. But we also started the process of replacing it with an API called Gateway. Gateway is a much more robust API, and it turns out is actually capable of expressing much of what service mesh APIs would have expressed, right? So the question then is, can we use that to normalize the API a little bit, at least the common path, so that users can have that same sort of portability that they're used to with Kubernetes core primitives when they're starting to go beyond the edges of their city. Another example here is some work we did in Multicluster SIG called Multicluster Services, which takes the concept of Kubernetes services and defines some semantics, not an implementation. It's not like a thing that you download from Kubernetes and run. It's a specification for how multi-cluster services can work, which then lets implementations go off and figure out, how do I offer this, right? And that is because it's very tied to how your network works. And already we can see there's, a handful of implementations out there that are offering different ways of giving the same semantics, so that at the end of the day, the application developers are the ones who use these APIs and they can rely on some project-defined semantics, but implementation-defined details.
Got it. Yeah, just doing looking up. We're going to include a link to the Gateway API that you were talking about in there. I think there's some really interesting as an example of that iteration that you're working on.
Right.
So CNCF is a big part of the Kubernetes. I mean, that's the biggest part of Kubernetes. How involved in CNCF are you? And do you keep an eye on other projects, or how do you look at the ecosystem as a whole? CNCF obviously is critical to the success of Kubernetes and ongoing. I'm not honestly super involved in it. I'm not on the governing board or anything like that. Those sorts of roles don't suit me. But I do pay attention to the projects that are going in and the ecosystem and the chatter about those projects to see sort of what's coming out, right? The reason Kubernetes was successful is that it was an opportunity to compete with the established players. So I like to watch what the new guys are doing as they're coming up. But I'm not super involved in it. I do some work with running our Kubernetes infrastructure, which serves like the website and all of our downloads and those sorts of things, which is officially run by the CNCF but funded by grants from Google. And so that's my biggest point of contact with the CNCF right now. Yeah. So Tim, really appreciate having you on here. One thing I wanted to ask before we jumped off was if some of our listeners want to contribute to let's just say the networking SIG or whatever, where do you suggest they get started? Where's the best place for me to start as a developer if I want to help contribute and be a part of this?
So that's a really tough question because the system is large and reasonably well established. And what I mean is all the easy stuff is done for the most part. We're on to the hard stuff that is intricate and has subtle implications for the rest of the system. That's not to scare people away. Definitely, we welcome new contributors, but before you can just show up and start swinging, you've got to learn about something. Like, what is it that you're interested in? If it's the networking group, like, is there a topic that you're particularly passionate about or that you have some background in that you'd like to participate in? We have more bugs than we can shake many sticks at. And so coming in and saying, okay, maybe I'll work on some of the bugs around, we're talking about kube proxy. So I'm working on some of the kube proxy bugs, right? There are to-dos and things left in the code base. There are issues filed, although not as many as I'd like, that are labeled, good first issue. That's the way to get started. Show up at the SIG meeting if you can, or show up on the mailing list, introduce yourself, say what you're interested in and what you'd like to help with, what skills you bring here. We welcome all skill levels, whether that's doc writing or code writing or tests or whatever background you've got. Certainly, we have real networking, capital R, capital N experts on the SIG, and we have other people like me who are less so. We have all flavors. We're very welcoming, I think. So if you're interested in helping, the step one is just to show up. The advice that I give to most people inside Google and outside of, I want to start, but I don't know how to help. I don't know where to start with it. The usual answer is start with main. Pick a component that you like, that you're interested in understanding. Start reading the code. And I swear, if you can make it an hour without finding something you want to fix, you're not looking hard enough. Whether that's refactoring or renaming or commenting or moving stuff around to make it more readable, like new eyes are such a valuable resource that I hate to waste them. So if you're new to the project, pick something, start at main, and start walking through that code until you feel like you understand it.
That's an interesting approach. I think it's really good advice. So Tim, thanks so much for joining. I know you took time out of a really busy week where you have a lot else going on, getting 124, trying to do your part in that release. Definitely really appreciate you taking the time. I learned a ton, and it was a really interesting conversation for me.
Thanks for having me, guys. It was actually a lot of fun.
Thanks, Tim. Really appreciate the time.
That's all we have time for today. If you're the maintainer of a CNCF project and would like to be a guest on this show, head over to Kubelist.com. To learn more about Heavybit, visit heavybit.com to check out the library. It's packed with amazing talks and content on sales, marketing, product, and more for founders of developer tools companies. And this podcast is brought to you by my company, Replicated, where we enable cloud-native software vendors to operationalize and scale the distribution of their modern on-prem software to their largest enterprise customers. Check us out at replicated.com.